So in this video, we're going to put together what we've already learned about amplitude and periods to plot things that look like y equals a sine of bx or y equals a cosine of bx. So for example, we're going to sketch a graph of, part A, y equals 2 cosine 3/2 x. So in this case, our A here is 2 and our B is 3/2. So remember that B affects the period. So remember the period is equal to 2 pi over B. So in our case, that's going to be 2 pi divided by 3/2. And if I rework that with keep, change, flip, we're going to have 2 pi, change to multiplication, flip the second fraction, so 2/3. So we're going to end up with 4 pi over 3. So our graph, first off, we have a cosine function. So it's going to look like this. And then the one period is 4 pi over 3. And then remember the way that we get those other points on the axis. So we're looking for this middle point here, this point here, and this point here. So remember that this is our period P. This first point here is, remember, 1/4 P. This label is 1/2 P. And this label here is 3/4 P. So if I come over here onto the side and I calculate 1/4 P, it's going to be 1/4 times 4 pi over 3, or pi over 3. So this first label is pi over 3. The second label is going to be 1/2 P, so 1/2 times 4 pi over 3, or the 2's would cancel, or the 2 cancels with the 4 and we get 2 pi over 3. So this slot here is 2 pi over 3. And this last one is going to be 3/4 P. So 3/4 times 4 pi over 3. And the 4's cancel, the 3's cancel, and you're just left with pi. And then the second thing to notice is that the A is 2. And so remember the A changes how high, the amplitude. So our amplitude is equal to 2, which means we're going too high and too low. So these 5 points would be the 5 points that I would want to plug into Alex or show me on a test so that you get the problem correct. So we'll do one more example here. So B is y equals minus 1/2 the sine of 3x. So in this case, we're going to first start off by graphing the sine, but if you notice, my amplitude here is negative, which means instead of graphing, we usually graph the sine function like this. Instead of doing that, we're going to flip it over. So we're going to deal with our sine function being upside down, flipped over, reflected over the x-axis, and then our amplitude, so again, it's a 1/2, which means that the point up here, it's going as high as 1/2 and it's going as low as negative 1/2. And so now we just need to find those 5 points, right? So where those x's are. So we need this point, this point, this point, and this point. Remember, they come from finding the period. So the period is 2 pi over B. So in our case, that's going to be 2 pi over 3. And then remember, we have to find 1/4 P, 1/2 P, 3/4 P, and P. So we already know P. P is 2 pi over 3. So 1/4 P is going to be 1/4 times 2 pi over 3. So the 2 and the 4 would cancel, leaving a 2. So we end up with pi over 6. So that's this first place, pi over 6. 1/2 P is going to be 1/2 times 2 pi over 3. So the 2's would cancel, and we're just going to get pi over 3. And 3/4 p, we're going to have 3/4 times 2 pi over 3. So again, the 2 cancels with the 4, and you get a 2. The 3's cancel, and we just end up with pi over 2. And that's all you have to graph to be able to show that you know how to graph something where both the period and the amplitude are affected.